It's 1912. We're here at the Ateneo de Madrid, specifically inside the Laboratory of Applied Mechanics, where Leonardo Torres y Quevedo, arguably Europe's most advanced systems engineer, was about to build something that could change everything. This is Ajedrecista, the chess player. It doesn't look like much, but this machine possessed something no device before it ever had: autonomy. Ajedrecista was the first fully automated device that could sense its environment, process information, and make independent decisions. So how did a pile of brass gears and electricity manage to beat humans at their own game decades before the invention of the computer? And why does this mark the leap from simple automation to true autonomy? That's what we're going to dive into.
The art attributed more
to understand the magnitude of that leap, you need to understand the technological landscape of 1912. We had mastered steam and steel, using them to forge massive machines that literally built the world. But these machines were determinate. They followed a fixed, unchangeable path. They could repeat motion, but they could not make a choice. Now, the public had seen a machine play chess before. For 84 years, an automaton known as the Mechanical Turk toured the world, defeating luminaries such as Benjamin Franklin and Napoleon Bonaparte. But it was a hoax. A human chess master was hiding inside, moving the arms with levers. That legacy of fraud caused deep skepticism. Edgar Allan Poe argued that a true chess machine was impossible because while calculation was determinate, chess required judgment, a quality he believed couldn't be built from gears. In fact, Claude Shannon would later calculate that there were more possible games of chess than there are atoms in the entire universe. So, how did Torres create the first chess-playing machine without creating a universe-sized calculator? He narrowed the problem. Instead of solving all of chess and having to deal with a universe of variables, he focused exclusively on the endgame of king and rook versus king. And that created a finite set of positions that you could map. If you can map it, you can solve it. To show you how the machine worked, I'm going to demonstrate the three-phase cycle that gave Ajedrecista its autonomy. First, sense. The board is a grid of open circuits, and each chess piece acted like an electric jack, similar to what you find on wired headphones. When you place a piece on the square, it closed the circuit. This sent a signal to two sliding bars that would keep track of the piece's exact coordinates, and that process was repeated for all of the pieces. So now the board state was established, and the machine knew where everything was. Time to think. The logic was surprisingly simple. Torres divided the chessboard into three vertical zones: left, center, and right. Then the machine followed 6 if-then rules based on 3 behaviors. Rule 1. If the black king is in the same zone as a white rook, then the white rook moves away horizontally. This behavior was designed to keep the rook safe. Rule 2. If the black king is not in the same zone as a white rook, and the vertical distance between the black king and white rook is more than 1 square, then the white rook moves down 1 square. This behavior was focused on confining your king by slowly eliminating the rows you were allowed to play on. Rules 3 through 6 were designed to coordinate the attack. This was a parity check to make sure the machine never accidentally caused a stalemate. Once the logic locked in the best move, the machine physically moved each piece. Sense, process, act. This cycle was robust enough to achieve checkmate every single time. But here is where it gets interesting. The most sophisticated part of the machine wasn't that it could play, but that it could judge. Torres programmed the machine to validate the opponent's move against the rules of chess. If you tried an illegal move, the machine would light up a bulb and refuse to move. 3 illegal moves, and the machine would entirely shut down. It essentially rage quit, and that capacity for rule validation moves beyond mere calculation and into the realm of judgment, a core component of true autonomy. In 1920, Torres and his son built a second version, replacing the mechanical arms with electromagnets beneath the board. Now the pieces moved as if by invisible hand. But in the end, the hardware became obsolete, and none of Ajedrecista's gears or circuits survived into the computer age, its legacy entirely conceptual. Ajedrecista was the first tangible proof that a domain of human thought could be formalized, that judgment and strategy weren't mythical properties of the mind, but could be broken down into computable steps. Torres proved that machines could follow heuristic rules and make decisions, and in doing so, he established chess as a primary testing grounds for every generation of artificial intelligence that followed. Ajedrecista stands at the head of this lineage, the first real chess machine, not a trick, not an illusion, just a pile of brass and electricity that learned how to think.